So in this video we are going to learn about series and parallel connections. So it's very simple. Just start from your supply. So you identify your supply, that is positive and negative. If it is a parallel connections, so take your load, whether LED or buzzer, identify their positive and negatives. For example, here I mark negatives here. For example, this is my LED 1 and this is my LED 2. So in LED 1, negative should be connected, and LED 1 also negative should be connected to the supply negative, and positive. Since I use a switch here, after switch, since this switch is connected with the battery, this connection is positive only. And in LEDs also, these two connections will be positives only. So positives we have to connect together. In parallel connections, all the positives connection will be together, connected to the supply, and all the negatives will be connected together and connected to the supply negative. So that is a parallel connection. In case of series connection, so we start from the supply, same thing. After battery, switch is there. So after switch, the voltage what we are getting is positive. That positive is connected with the positive of the LED 1, and since positive is connected with the switch, we are left with the negative connection. Here you can observe that negative is connected with the other LED positive. Positive and negative are interchanged in case of series connection, and then we are left with the negative. That negative will go to the supply negative. In series or parallel connection, we'll start from the positive and end at negative, and it will never happen that negative is ending at positive connection. That kind of connection is called a wrong connection. So this is about the series and parallel connection.
This is our third experiment. Like, we are planning to make a series connection of LEDs. So for this experiment we need a battery cap, switch, resistor and 3 LEDs, because we want to connect it into series. So when we connect into series, only one thing we have to observe is that it has to follow the positive and negative connections. Fine. First I will connect the battery. So positive, like in the previous video, similar connections. Positive you connect either way, either direction in any of the columns, and negative somewhere else in any other column. Next is the resistor we have to connect at the positive terminal, so in the positive columns, and other end of the resistor, like resistor will not have any polarity, you can connect in any directions. So resistor is connected. Next is LED. So once you start LED, positive is there. So first we have to connect at the positive with the resistor, and negative in any other column. Next, second LED, since we are planning to connect 3 LEDs in series connection, so it was negative connection here. On that negative I have to connect the positive of the LED. In that same column I am connecting the positive. Negative I am connecting somewhere else in any other column. Next, one more LED. So there I will be connecting the positive. In the last negative of LED I am connecting positive, and last LED negative I am connecting somewhere else. So once I connect the battery, LED negative. So last connection was negative. So in the negative I connected the battery negative. So lights are glowing. They are all in series connection. In series connection, what happens? It follows the current. Like, if any one path is missing, if any one LED get damaged, remaining other LEDs will not work. See here, if last one gets damaged, it will not work, or first one gets damaged, all will not work. So this is one thing about. So this is about series connections. If any of the connections are missing in series, all the connections will get open circuited. In that case, LEDs will not glow, current will not flow. This is about series connection. Next, we are planning to make a parallel circuit using 3 LEDs. Same components: battery cap, switch, and then 3 LEDs with 1 resistor. First connect the battery, red positive in any of the columns, and black negative in any of the columns. Then resistor is not having any polarity. Either way, just connect at the positive column, any column, and other end of the resistor somewhere else. Then parallel means all positive will be together, all negatives will be together. So positive of LED I have to connect in the resistor other end because that is the positive. Negative in some other column. Same. So here also some columns are there. In the same column, negative also in the same column, positive in the resistor column because that is the positive connection coming from the battery. Now all LEDs are connected. So but negative connection of the battery is here, so I have to move it into the negative of the battery. See here, all LEDs are glowing now. This is a parallel connection, all positives together, all negatives together. If I remove any of the LEDs, remaining others will be working only, because in parallel connection current will be flowing. It will not form an open circuit in case of any LED gets damaged. So this is about the parallel connection. See, if I remove the middle one, still remaining two are working only. If I reconnect it, all three will be working only. This is about parallel connection. All positives and negatives are connected together.